Alrighty, guys. Happy Tuesday, the 31st, last day of March. April is right around the corner tomorrow. I miss seeing you guys. Hopefully, some of you reach out just to say hey sometime. That'd be cool. Um, Today is section 7, which is on geometric probability. It's also the last section of chapter 10. And oh my goodness, I can hear those groans from here. Yes, there's a test coming soon. It's probably going to be, I think, Tuesday. So a week from today. I'll give you a little extra time to review and do all that stuff to get ready for the test and ask questions. So hopefully that'll get you where you need to be. So look forward to that. So this last section is on probability, and it's geometric probability because a lot of the problems deal with some pictures that are some kind of shape, but it's really just probability. No big deal. So just in case you don't know, probability is the number of favorable outcomes divided by the number of total outcomes. In geometric probability, you're going to be looking at segments or some kind of plane figure to figure out the outcomes. Um, so, uh, the first type of problem you'll see is probability on length. And it says that, so here's how you would do that. If you had this line segment and these 4 points on it, it says if point S is chosen at random on this whole line segment, the probability that S would be on MN would be the length of MN over the length of AB. So not difficult stuff. So let's look at an example here. Here's our line that we're going to be looking at. It says point K on ST is chosen at random. We want to know what is the probability that K would be on QR. So pretty simple. First thing, how long is ST? It starts at 2. It goes all the way to 14. That's a length of 12. How long is QR? It starts at 5, goes to 8. That's a length of 3. So the probability that it would be on QR would be 3 out of 12, which reduces to 1/4, which as a decimal is 0.25. So whatever they're asking you for, either as the fraction, you always want to reduce it, or as the decimal, remember just 1 divided by 4, or whatever your fraction answer happens to be. Okay, here's another one. If you want to try it, go for it. Otherwise, it's pretty simple. Point H on segment ST is chosen at random. What is the probability that H also is on SR? So again, we know how long ST is. It is 12. How long is SR? From 2 to 8. That is a length of 6. So that would be 6 out of 12, which is 1/2 of the times, 0.5 as a decimal. Simple stuff. Let's do another one. A commuter train stops at a station every 25 minutes. If a commuter arrives at the station at a random time, what is the probability that the commuter will wait at least 10 minutes for the train? Okay. So, just think about this scenario. What's the probability that he would wait at least 10 minutes? So at least 10 minutes would mean he either has to wait 11 all the way to 25 minutes if the train just left, right? So how many minutes is that from 11 to 25? That's of course 15 minutes. So there's 15 minutes where he would have to wait more than 10 minutes. And there are from 1 to 10 minutes, I guess, would be 10 minutes where he wouldn't have to wait at 10 or less, right? So, what's the probability that he would wait at least 10 minutes for the train? So that's going to be, if he waits at least 10 minutes, that's going to be 15 minutes out of a total of 25 minutes. And if you reduce that, it would reduce by 5 to 3/5. So that's going to be 0.6. That's 60% of the time. 60% of the time. So there you go. What is the probability that he would wait no more than 5 minutes? That would be 5 out of 25. That's 1/5. That's 0.2. That's 20%. That's not hard today. The back is a little bit tougher though. When we're looking at area, so we're going to, whatever we're looking for, we're going to take the area of whatever we're looking at divided by the area of the entire region. So that's how you find the probability of an area. So here is an example of that. A circle is inscribed in a square. Point Q in the square is chosen at random. We want to know what's the probability that Q would land in one of those 4 shaded regions. So you need to know 2 things. You need to know the area of the shaded regions, and you need to know the area of the entire figure. So how would we figure out the area of the total figure is easy. Area total. It's a square, right? So 6 by 6, that's an area of 36 for the total. Now for the shaded region, that's a little bit tougher. To find the shaded region, we would have to find the total area and subtract the area of the circle, right? So it's going to be the total area minus the area of the circle. And we know what area of a circle is. It's pi times radius squared. So in this case, our radius would be 3 because the whole length is 6. That would be a diameter. So the radius is going to be 3. So 3 squared. So that's going to be 36 minus 9 pi. So good time to pull out the calculator. 36 minus 9 pi. That's kind of gross. I don't know. Maybe I'll just keep it as 36 minus 9 pi. That is the area of the shaded region. So the probability is going to be the shaded region divided by the total area. So I'll just type that whole thing into my calculator. So I'll do that 36 minus 9 pi, I already have it, divided by 36. So 0.215, I guess. So 0.215 if I round it to the nearest thousandth, or 21.5% is the expectation. So it's a little bit over 1/5 of the entire region. We've got another example similar to that one. It says a triangle is inscribed in a square as well. Point T in the square is going to be chosen at random. We want to know what's the probability, once again, that it would be in that shaded region. Okay, so again, we need to know the area of the total figure, and we need to know the area of the shaded portion. And then we just do the shaded divided by the total, right? So the total figure, again, it's a square, so 5 by 5 is going to be 25. So the area of the shaded region, we can do the total minus the white triangle, right? So we know the total already is 25. And the triangle, what's the base? So the white triangle is going to be an area of a triangle, so base times height divided by 2, right? What's the base of that triangle? Of course, it's 5. And what's the height? Also 5 divided by 2. So that's going to be 25 minus 12.5. That's 12.5 for the area of the shaded. So my probability, I put my shaded over my total. Type it in my calculator, although I don't need to. I know that this is 1/2 or 0.5 or 50%. So let me know if you need any help with any of these while you're working on my math lab. Again, this is the last section, so we'll start a review tomorrow. I'll post a video again of some example problems, and then you'll get a day or two to work on that, and we will continue talking. All right, so talk to you later. Short video today. Good luck, good luck, good luck. See ya.